We have nearly 300 people joining us on Zoom from all over North America. And we think maybe a couple who have also registered from the Pacific, possibly as far away as Australia or Singapore. I'd also like to digress for a moment and point out that we have a distinguished scientist, a member of the National Academy of Sciences, Mr. Stan Hart, Professor Emeritus, Woods Hole Oceanographic Institute is here. As Scott said, my name's Brian Lane, and I serve as a chair, more or less, of a little group of people down in Green Valley called the Climate Crisis Team. And basically what we're all about, since we have, as retirees, not much else to do, is to find a way to put together meaningful public programs that basically bring the message about climate change, how it affects the oceans, the atmosphere, and the land that we live on, and where it's all going. Now, we don't profess to be the experts to do this. We're just the producers of this movie. But that is our job, and we're very fortunate that we can partner with someone like the OSHA Lifelong Learning Institute, as well as fortunate in having so many skilled scientists, researchers, and educators from University of Arizona that we can call on. And we're going to call on one right now. She's a rock star in her own right. She is a department head of the Department of Geosciences at the University of Arizona. She is also a Harvard grad, a PhD from Scripps Oceanographic, University of California. She heads up the climate team for NOAA in terms of producing models for the study of climate changing, and owns a whole fleet of robots that she puts out in the Southern Ocean. So without further ado, I'd like to welcome Professor Joellen Russell. And I think you guys are really not only going to learn a lot today, but you're really going to enjoy the heck out of this.
Thanks,
Joellen.
Brian.
What's happening?
I'm good. Thanks for joining me. I'm always a little nervous that it'll just be in the crickets, so I'm grateful for all of you to show up and listen to me tell you a little something about the fun things we're doing at the University of Arizona and basically all over the world. And I like to start here. Let's see if I can get this to our tiny pale blue dot. It's Voyager, right? Turned around and took a picture of home. And it's the only blue planet we've ever found, right? Thousands of other planets orbiting other suns, and the only one we've ever seen that's blue is our home, this little one. And what's amazing about this is that we spend a lot of time looking at the 28% of the planet that is land, but the 72% of the rest of our planet is what makes it blue. It's our ocean. And that ocean, that one ocean, which mixes all the waters together, they're all connected, is kind of extraordinary in what it's doing under climate change. So I'm going to tell you this kind of fantastic story. And I have to set the stage just a little bit. The American Geophysical Union, which is our, you go to their AGU meeting in San Francisco and there are 24,000 geoscientists. It is a huge meeting. It's like reunion week for me. I have a great time, basically. But what the AGU tells us is that there are roughly 600,000 geologists working in research in the world today, and there are about 60,000 meteorologists working in research on the atmosphere today, and there are about 6,000 oceanographers working in the world today, and about half of those are marine biologists who work on things like penguins or whales or fish. This is when they say the thin blue line to me, sometimes I think about my colleagues. I bet I know almost all of them. I mean, this is a tiny community. This is not like a huge community. And we're more leveraged, meaning we cannot do our work without a ship. You can't. How are you going to do that? How are you going to go out and see what's actually there on the 72% of the Earth's surface that isn't land? It's not like I can do like my geology colleagues in my department and just put my boots on and drive my truck. that it's not an option. I need a boat or a satellite or a robot float, but you got to have some, pretty serious leverage to be able to look at this. And it's huge. It's far bigger. All the geologists, we need all these geologists to look at the land. I'm like, sure, Stan. All these geologists, right. And what I love about this one is everybody always looks at it and says, that is really beautiful satellite data. That's how we see the oceans, right? Satellite data. This is not satellite. This is the 3-kilometer forecast model, ocean atmosphere climate model that we are currently using at the National Weather Service at NOAA to forecast your weather forecast. And if you like your weather forecast, thank an oceanographer, but because in fact, almost all the gains, improvements in weather forecasting, remember when we could only barely get 5 days and then it was 7 and all of a sudden it's 10 and it's pretty good 10, not a bad 10. It's because we finally started looking at the other 72% of the Earth's surface and go, guess there's something coming in. No, really, everybody jokes, but the ECMWF, which is the European Center for Medium Range Weather Forecasting, they moved to an atmosphere ocean model, what we call a climate model, in 2004. Want to know when the Weather Service moved? 2016. And it was after a bake-off. They actually had a bake-off between the Weather Service model and this lovely bad boy, which is the GFDL, Geophysical Fluid Dynamics Laboratory at NOAA, where I used to work, I'll admit. Come on, I'm biased. I'm totally biased. This is FV3, the Finite Volume Core 3, and the original FV1, I'm actually a co-author on that paper. Thank you very much. So I really am biased, but this was how we started making progress again. And so everybody said, well, maybe eventually we get so good at weather modeling that we can use it for climate. That's not at all what happened. We got so good at climate that we started using it for weather. Yeah, I know. All the people are like, well, you guys aren't, those climate models, they're no good. I'm like, oh, really? Let me show you how awesome they are. And the reason we need the ocean is because so much is happening on a global basis. This is atmospheric CO2, and the black line, that's at Hawaii. That's at Mauna Loa, the little wiggle. The red line is the South Pole. Yeah, the atmospheric CO2 increase is absolutely global. All of our CO2 mixes around the world in the atmosphere within a year. Yeah, 1 year, that's it. And it just keeps going up. This is Dave Keeling. He's not with us anymore, but he was one of the first professors I met when I started working as a grad student at Scripps. And I was poor as a grad student. I was broke. I barely made my rent and first month's deposit on my and so I had a brown bag, and I went down to the picnic tables at near the beach at Scripps, and he was the only one with a brown bag, and he was sitting all by himself at a picnic table. And I thought, okay, I'll just sit down. He says, hey, who are you? And I said, hi, I'm Joellen, and I'm going to do carbon in the ocean. It's going to be awesome. And he said, my name is Dave, and I do a little carbon work myself. This guy's curve, and Stan can tell you, this curve is carved on the wall of the National Academy of Science. It's considered one of our great triumphs as human beings, that we understand what we're doing collectively all together to terraform our planet again. It's a big deal. So just so everybody understands what global warming really is, Earth's radiation budget experiment is a series of satellites that sit out at the edge of the atmosphere, and they look out at the sun and in at the Earth. And they measure how much sun is coming in. It's about the same all the time, very tiny little variations, but about the same as coming in and getting out. That's global warming. Same coming in, less getting out. And we measure that. We know how much less is getting out. That's the top of the atmosphere energy imbalance, which we experience as warming in our atmosphere. We're going to get to a subtlety here in our atmosphere. How much more warming? Okay, so this is what's causing the warming. This is what we call the annual greenhouse gas index is basically the radiative forcing. How much of the warming is responsible for what? This is mostly carbon dioxide. you can see there's a little bit in CFCs. This blue is the methane. For everybody here who's a methane nut who says, oh my God, it's the methane. Yeah, it's about the same as it was in 1980. It's not that different. Actually, the radiative forcing for methane, it has increased, but it's just not that big a difference because it only has a 10-year lifetime in the atmosphere, so it doesn't accumulate. Whereas the CO2 has a 600 to 800-year lifetime in the atmosphere, and it keeps accumulating. It's a big deal. It's the carbon dioxide, just so everybody understands. It's what's keeping the radiation from getting back out. It's why we have a net energy imbalance. Yep. Okay, so this is what it looks like. And just by the way, just check out that last year, 2023. That's ridiculous. That's a ridiculously large warming in 1 year. I won't talk about that too much today, but there are reasons, ocean reasons. Okay, so top 10 hottest global years are these, the last 10. Seriously, they're not in the exact order, but the last 10 years have been the last 10 hottest on record over the experimental period of time. That's just it. So no more messing around. And that's a huge bump up in 2023, as you can see. We are the third fastest warming state in the nation after New Mexico and Alaska. Alaska because they're polar, New Mexico because they're drier than we are. We are also the third fastest warming city. Right after us is our friends just up the street in Phoenix. They're the fourth fastest warming city. So Arizona is sitting in the hot seat, in the bullseye of climate change for the United States. We're it. You and I and all of us in Arizona who love and adore our saguaros and our hiking trails and our, everything from river rafting to cattle to everything we like that's outdoors. Personally, for me, as a mom, the number of hot days per year has gotten more and more and more, and I get worried that I will not be able to throw my kids outside to play, and I'll need another drink. That is just a lot. It's a lot, and that increase is a lot. 12 more days above 110. 20 more days above 105 in Tucson, 19 more days above 110 in Yuma. This is what it looks like. Global warming is longer goddamn summers at ridiculously warm temperatures where it's not safe to put your pets out, to put your kids out, to let them ride their bikes. My daughter came back after a bike ride a couple of summers ago she was clammy, she had a headache, she started to get a rash. I mean, she had heat stroke. She was only out for 40 minutes and she's on a bike. She was covered up. She wasn't sunburned. It was just the heat. It scared me. Honestly, it scared me. And I'll show you at the end what I started doing. I have an outreach project that I do now. But this is what it looks like. And this is true. This is like how many days you need to water your cattle. How many days do you have to really put twice a day watering on your drip lines, to keep your plants from dying? That's what this is, more of those days. So it's also bad for things like our reservoirs and Lake Mead and the runoff. So that is what it was. We've had some recovery, but recovery to 38% full. We're gonna go right through that either through evaporation or drinking it, but okay. So Arizona has some pretty specific climate prediction needs. We're on the hot seat. We've got, extreme summer heat. Those are the incidences of heat waves. Notice that 50 years ago, it just didn't happen. Not like this. Total different scale we're on. Statewide average temperatures. This is our reservoir dropping. This is actually not far from the back end of my house, the Arroyo flooding, because when it does rain, it just comes down with a crash in the summer. We'd also like some high-tech jobs. These are great, right? Prediction saves money, makes money, is, better investments all the time. Why build something that's going to have to be retired in 10 when you could build something that's easier, cheaper, and better that'll last 50? I mean, it just makes sense. So global warming is really ocean warming. So that warming that I just showed you and the impact on Arizona is at this little tiny pink line. It's about 3% of the energy imbalance of the planet. 93% is ocean. We depend on what happens to our ocean to know what will happen to us in Arizona. We are ocean people, whether we know it or not. We don't have a coastline. We don't have a cold current offshore. We don't have a deep, deep, deep forest. We don't have a deep, deep, deep lake. We just have whatever the global mean is what's going to hit us. The hottest end of the global mean is what's going to hit us. So whatever the ocean doesn't take up is what we get. So I study the ocean. One thing, and I know this is too complicated and I don't expect you to understand it fully, but the ocean's heat uptake is the difference between equilibrium climate, like thousands of years from now, when the ocean catches up to our atmospheric change, it'll be that equilibrium climate sensitivity takes about 2,000 to 3,000 years to get there. Now, transient climate, what's happening right now, is a lot slower because the ocean is cold. It's basically cold like 1,000 years ago cold. Most of it has not seen our human atmosphere yet, and it's providing some air conditioning. And it's going to keep doing that for as long as it mixes and hasn't come into contact with our human atmosphere. So this is why it's so important to study our ocean, because it's basically like studying our air conditioning system. Is it going to work? How long is it going to work for? What if it shuts off and all of the cold water just sits down there and is not exposed to the atmosphere, does not take up our human-derived heat? We could see some pretty abrupt warming. That would be really serious. Now, this is Norfolk. I was just there last week giving a talk at Old Dominion, which sits right next to the Norfolk Naval Base. It's our biggest naval base in the United States. And whenever you put heat in the ocean, the molecules, you know, the little bit warmer ocean, they bump around against each other and they take up more space. So warming the ocean equals an expanded ocean, which means sea level rise. So 1.5 degrees C of warming in the atmosphere equals half of Norfolk underwater. 2 degrees of warming is almost all of Norfolk underwater. And 4 degrees of warming in the atmosphere is all of Norfolk underwater. So if you knew the enemy was coming to take your greatest naval base in 20 years, you know, between 10, 15, 20 years from now, what would you do? What would we plan? What would we start building if we knew they would take it, knew they were coming? We'd take steps. And I just want to point out, this was actually in the news. This is from the U.S. Army Research and Development Center, and that's the nuisance flood level. I just want to point out, let's see if I can get this to work. Notice that back here, there was almost no nuisance flooding. By the time you get here, it's all the time. And just by the way, you want to know who gets flooded first? At the Naval in Norfolk? It's the officers' quarters. They have the fancy views and are closest to the beach. And they're literally their back steps. They're getting water all the way up over the lawn and onto their back steps. So the Navy says it's a big priority. I only laugh a little bit, but it's true. So not only does it get warmer, when it gets warmer, it also affects our ecosystems. Coral bleaching occurs when the coral polyps boot the little algae in their skin that gives them all the beautiful colors. They're the photosynthetic algae. They live in the skin as symbionts of the polyps. So the polyps are meat eaters, and the zooxanthellae are photosynthetic, and they live together sharing, except when it gets too hot. And then the polyp kicks them out to try and save their lives so they don't cook the little zooxanthellae. And those little algae, once they're kicked out, if it doesn't cool down within 6 weeks, they all die. First the zooxanthellae and then the coral polyp. And then when you see coral that's been bleached, it's because they booted their polyps out, and we're waiting and hoping that maybe they'll get to reabsorb them if it cools down. But on our planet, that cooling down is less and less, and we have killed about half of the Great Barrier Reef, which took 1 million years to build. It's a really big deal. It's one of the wonders of the world. If you haven't seen it, I always tell them, you know, if you have grandchildren and you'd like them to see what the Great Barrier Reef looks like, time to plan right now. Don't wait. Don't wait. It might be 10 years where most of it's wrecked. I really mean that. That's a horrible thing to say, but don't wait. Take them now. Take them soon. It's dying. It's dying because it's getting hotter, and there's no choice here. It's inevitable. We're putting the CO2 in the atmosphere. It is killing it. But okay. See, this is what our shipping looks like. We use the ocean. It is our super highway for goods. This is how we get things back and forth and all around the world. And what you're seeing is just 15 days in 2012. That's it. You've got containers, dry goods, liquids, gas, vehicles. It's a huge deal. Did you know that it's 1,000 nautical miles shorter to get from Europe to China and back? Just one direction, 1,000 nautical miles shorter if they go through the Arctic? Yeah, and the ice is melting. It's at an all-time low. And that melting ice is creating lots of opportunities for cruise ships, for shipping, et cetera. And one of these days there's going to be a flash freeze. We don't do dynamic sea ice prediction at NOAA yet. We do statistical prediction. Do you think we could use 5 years ago to predict what's going to happen next year with it melting this fast? Absolutely not. I wouldn't trust it. You shouldn't either. But imagine, okay, big cruise ship, 1,000 Americans on it, and they're trying to outrun the ice. And it flash freezes in, and they're in 500 kilometers of sea ice. First, it's an inch thick, and the ship is making progress. Then it's 2 inches 2 inches thick, and the engines start straining, and then they fail. And everybody's on FaceTime telling everybody we're stuck, and it's getting cold and there's nothing to burn on the ship. When's somebody going to come get us? And you know how many icebreakers we have in the Arctic right now? Anybody want to guess how many we got? One. It's one. Nice guess though. Well, you were. That's fair. Most people are like 8, 15, of course. I'm like, no, we have one. What's the likelihood you could get some? Okay, here's what happens. Red phone on the president's desk ring. Ring, 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 ring. President picks it up. Comrade, I could do you small favor. In return, you give me Ukraine. Their ports are right there. They have nuclear-powered, double-hulled ships right there. We have one icebreaker. I'm not a fan. This worries me. The same way I would like you to go see the Great Barrier Reef. I'm making a prediction here. This is going to happen. He already has ships there. He's already ready. And we are putting more and more commerce and people through the Arctic. And of course we are. It's 1,000 nautical miles shorter. Of course we are. And we have one icebreaker. This is not safe. We don't do wave prediction globally. We only do it for our coastal waters. I also find this to be a problem because, so you can't really see it. I'm sorry I made this too small, but around Alaska, there's only this kind of thin skin around them where we actually do wave prediction, how high are the waves going to get, et cetera. Now that's a problem because we wrecked the Kulik, right? How high were the waves going to be? They didn't know. They were just outside the range. It's not good. Other things, how about the collapse of the Bering snow crab fishery? Took us almost 1.5 years to figure out what happened. We thought maybe the Russians fished them out or there was disease, or maybe they just moved next door and we've just missed them. But it was the first time they tried to declare a disaster, an emergency for the fishermen, like that, because there was 0 crab there. Turns out they all just starved to death. There was too much warm water, not enough mixing, not enough phytoplankton, not enough food, and they died. It took us a while to figure that out. We don't do dynamic fisheries prediction like in a global sense. We only do it in certain local markets. And then again, I want to show you where the Chinese fishing fleet is. And this I totally stole out of the New York Times. Notice that that's the exclusive economic zone for the Galapagos and for Ecuador. And where are they sitting? On/1 foot over the line on occasion, because how big a navy do you think Ecuador has? They don't. All right, how about Argentina? They have a little more. They've built 200 of these. Do these look like fishing ships to you? They sure don't to me. They look more like Navy cutters. Notice no nets on the back. And a lot of signals processing there for a, regular old fishing boat, but they have 200 of these. Want to know how many keels we're laying for oceanographic research right now? One. Want to know how many we mothballed last year? 2. So the number of days we can go to sea, remember I told you how, there's only 6,000 of us worldwide. That's not Americans, that's everybody, right? And America has fewer ship days to go do research of any variety. Since 1989, they have been coming down, 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 down with no replacements. We mothball them, we don't replace them. We mothball them, we don't replace them. Now, part of this today is because the Navy's laying keels like crazy because they understand that we are losing. Okay, I'm going to say something, and I am not a security expert, but the tripartite nuclear strategy for the United States, the way that we keep the détente with Russia and China, is we had our ICBMs, right? We worry a little bit about Iron Dome and them knowing where all of them are, but there's one. So that's not very effective at the moment because they know where they are in Iron Dome. And then the other one is B-52 bombers, which are stealth, not so stealth when you're looking from above, from satellites, which China has deployed everywhere now, right? And so is Russia. And then of course there's the third one. What's the third one? It's nuclear subs. Right? We hide them in the eddies and currents of our ocean because they can't see the displacement of the ship if there's enough noise in the ocean to hide it in. So the race is, how fast can our oceanographers stay ahead of the Chinese and Russian oceanographers? Can we model and predict our ocean better than they can? Because we hide our subs from them and we can see theirs. So I sent one of my best students 2 years ago to the Naval Research Labs to do high resolution ocean modeling because we do this a lot in my lab, and he's very, very good when he got his PhD, and he wanted a real job. He didn't want a postdoc. He didn't want to work for academia. He wanted a real job. So he went to work for Naval Research Labs, and a year later, he was hired by a big bank for triple the salary to be a climate analyst. Couldn't keep him with the Navy no matter how hard we tried. So, and I just want to point out, ocean budgets as a total of the National Science Foundation are at their all-time lowest, right? Less than 5% of the funding we put as Americans into research is put into oceans. 72% of the Earth's surface, 93% of the heat budget, 40% of the protein that is consumed by developing countries, and 1 out of 4 carbon molecules that comes out of anybody's tailpipe anywhere in the world within a year. All oceans. And we put less than 5% of our research budget into it. And yeah, there's that nuclear stool, blah, blah, the Arctic. There's some things, some reasons. Just by the way, parts of this is part of white papers that I've been writing as the chair of NOAA's Science Advisory Board's Climate Working Group. I and my colleagues have been writing these white papers and submitting them and making NOAA actually respond to us how the National Oceanic and Atmospheric Administration, how they're going to actually accommodate these, what we think of as hair on fire emergency level, bang it. Sorry, but, and we've been doing it, and they just keep showing us their pockets and saying, no money, we couldn't possibly. All right, so trust but verify. Carbon accounting, all that carbon, where's it going, and how's the ocean doing the job? And I'll just point out, it is actually the law of the land. The Supreme Court ruled in 2007 that the Clean Air Act actually covers carbon dioxide. Now, you'll say, but wait, there's no regulation on this. I'm like, you're right. We don't actually have the regulation. It is the law, but it's not regulated yet because every time the EPA proposes a rule, everybody has a aneurysm, and they don't, so it hasn't really been implemented. But we also have the Paris Agreement, also non-binding. We got out of it for a while and then we got back into it, but non-binding. And this is actually the world carbon budget: electricity and heat, buildings, manufacturing, construction, transportation, fugitive emissions, industrial processes. Look how tiny that is. This is tiny. Agriculture, 11.6%, also not that big. Land use change in forestry, 3%. So, things that you might have heard from the news as being a really big deal. I'm like, not really. Most of it is stuff we control. Yeah. Okay. So I bet you didn't know that the US has dropped more than 20% of their total emissions since 2007. 20% off. This year alone, we dropped 3%. 3% off our carbon emissions while growing our economy, having an all-time record in the S&P 500 and our largest ever population. We're just decarbonizing the economy and making a buck while we're doing it. This is a huge deal, and you never see it on the news. I'm like, man, if I had my way, it'd be like a little ticker. Like, here's the stock market, here's the temperature, and here's how much we've cut. You know, we used to be 22% of global emissions. You know, we're only 13 now. And by 2032, we're going to have met our Paris Agreement of cutting 50% off. Now, we're 2 years late. You know, we said we do it by 2030, but boo-hoo, we're going to make it by 2032. And on the world's greatest, we used to be the world's biggest emitter. And we're not even close anymore. Not even close anymore to being the world's biggest. It's China. They're just rocketing up. So just here we are, 50%. You know, when we hit in 2032, we'll only be 6% of global emissions while still being 22% of the global economy. I know. So everybody's like, oh no, doom and gloom, bad things. When we cut CO2, I'm like, no. The evidence for that is zero. Okay, so where does it go when we burn it, right? It could be fossil fuel. Okay, if you burn something, almost anything, whatever you're burning is probably adding carbon dioxide to the atmosphere. Plastic, pellets, wood, coal, gas, you name it. If you burn it, it's probably adding CO2. It's probably a long chain hydrocarbon and adding CO2 to the atmosphere. Seriously, don't burn it. Everybody's like, landfills are bad. I'm like, landfills are great. No, really. Municipal waste disposal. Here's the solution to plastic in the ocean and, single-use plastics of any variety. Take it out of the ground with a non-carbon dioxide source of energy. You use it very carefully, and then you stick it back in the ground. Zero effect on the atmosphere of any variety. That's all it takes is careful. All right, two quarters out of a buck. 2 quarters stay, 50 cents stays in the atmosphere and hangs out for 600, 800 years. 1 quarter goes into the ocean, 1 quarter goes into land plants as they green. This is where it goes. And this has been true for a long time. So what I do is I think if I know the atmosphere really well and I know the ocean really well, I could actually tell you what everybody's doing, not just their fossil fuel emissions, but their land use change, whatever they're burning, wildfires, their fisheries impact, the pig poop running off into the ocean, all of it. I could actually measure each country's impact. Okay, I'm not going to get down to little tiny weeny ones, but they aren't the real problem, are they? Most of them are big ones like Russia, Canada, US, Brazil, China. These aren't little. Indonesia, these are huge, the whole EU. We can do this. So the other thing is we got all these people saying we're going to do carbon dioxide removal. Okay, we have one proven, scalable, always works way to keep carbon out of the atmosphere. Just don't burn it. All the other methods either don't scale or are extremely expensive, or you have to burn more fossil fuels in order to make them go. None of which is great, okay? So I'm sorry, they put me on 5 different National Academy panels in the last few years, and I'm always that grumpy old guy on the end who's like, and that won't work. Nope, that won't work. I mean, I feel terrible because the young ones are so excited and it'll be great. We should all invest. And then their startup goes belly up and I feel bad, but I'm also like, yeah, no, because you're putting a lot of energy in and that energy is coming from where? Fossil fuels. So you save nothing. Bummer. Okay. So when we talk about the ocean, we usually talk about there could be the solubility, which is how much just dissolves in because we've got so much more in the atmosphere and the ocean hasn't seen our human emissions yet. Or it could be through biology where it greens up and then it dies and it sinks. Now I'm going to, this is me, the grumpy guy on the end, right? The upwelling, that's what I'm going to talk to you about today. You can have all this happen and you can have all that happen. But if this happens, I don't care. It's gone. It's burped right back out. This matters a lot. So that mixing with which I'm going to help hide our subs, and I'm going to be able to tell how much carbon can go into our ocean, how efficiently, where and how. Yes. So, and heat. So this is what an ocean looks like from an oceanographer's perspective. It's one big fat ocean all the way up to the Arctic, and it centers around my favorite ocean, the Southern Ocean. So if you were young, they probably told you there were 4 oceans: the Arctic, the Atlantic, the Pacific, and the Indian. The only ocean that really matters is the Southern Ocean around Antarctica, which has always been there, but people underestimated it. They didn't realize. Now, the next biggest current in the world is the Gulf Stream that runs off the east coast of the US, and it carries 40 million cubic meters of water a second. That's a lot. That's a very big current. You want to know how much this Antarctic circumpolar current carries, which is right here, this guy, or this pointer, right here around Antarctica? That's called the Antarctic circumpolar current, and it, not 40, 178. My baby can buy and sell that Gulf Stream baby. Sorry, Stan. Not that Hui isn't awesome, but you know. So this is the Southern Ocean, and 85% of all of the you always talk about North Atlantic, overturning. I don't know if any of you have heard about the North Atlantic, the Atlantic meridional overturning circulation and how Europe is going to turn cold. BS. What really is going on is this wind-driven current around Antarctica. Because the westerlies wrap around Antarctica, round and around they go, they drive this enormous current that actually scours the bottom. It's called the Antarctic circumpolar current, and it's enormous. And because it pushes water away, it's a left-hand rule with the Coriolis in the southern hemisphere, so it pushes water away in all directions around Antarctica. See this little arrow here along the surface, pushing it away. Because you can't have a hole in the ocean, you have to replace that water that's being pushed away from somewhere, so it comes up from below. It upwells. Remember, I was telling you, it's all about the upwelling, and 85% of the upwelling happens right here. So the Southern Ocean by itself accounts for 67 to 98% of the extra heat going into the ocean. Almost all of it. It accounts for half of the ocean uptake of carbon. So there's a whole global ocean, and half the carbon goes in around Antarctica, the other half is distributed all over it. And the vertical exchange, the up, actually brings up the nutrients that fertilize almost 70% of our global ocean. It's the amount of fertilizer available for the plants comes from up. So 50% of all the carbon dioxide that gets taken up by the ocean and 75% of all the heat at a minimum. That's why the Southern Ocean, everybody's like, why do you work in the Southern Ocean? It's miserable. The weather is bad. It's really, really cold. And why not Hawaii? Why do you rob banks? Because that's where the money is. We go to the Southern Ocean because that's where the heat and the carbon is. It's just miserable. Oh my God, the weather is bad. I've spent more than a year of my life at sea, south of 40 South in the Southern Ocean, and it is rough. You're hanging onto your seat and your dinner and the shower and the toilet, and it's bad. It's really bad. On a good day, it'll just be on the O2 deck on the bridge. It'll be a little spritz. On a bad day, it'll be blue because the wave will roll over the top and you'll just barely see a little light. And on a really bad day, the ship will heel into a rogue massive wave that'll just roll over the top of the ship and it'll be black. I still have little PTSD from wake up, the black water over your head. It's a big deal. It is. It's hard work. And that's why when you look at one of these oceanographers' maps, the continents are grayed out. The white space is the ocean. Red is where there are lots of measurements from ships. White is where there are none. And this is from 1999 to 2015, so 15 years. When I said we don't have enough ship days, I meant it. We're in trouble. We don't have enough ship days. So oceanographers are sneaky and awesome. And in about 2004, we started deploying robot floats. Now, these are stripped down robot floats. We've now made measurements everywhere. These robot floats can do an incredible amount of work. And these are just temperature and salinity. I want to know carbon, right? That trust but verify. How am I going to carbon account for 72% of the Earth's surface when I don't have enough ships? I'm going to get Southern Ocean Carbon and Climate Observations and Modeling. And that's my friend Jorge Sarmiento from Princeton, because when I first proposed this in 2012, I wrote a white paper. I'd already had a NOAA grant from a carbon process team for the Southern Ocean, where we were going to model how much carbon would be taken up, like an assessment of how much could be going in. But I didn't have enough money to get us new observations with a ship. It's $50,000 a day bare boat. 2 days, I might get 5 profiles. Now, one of these robot floats that I propose putting in, it is less than $100,000, less than the 2 days of ship time, and I get 250 profiles with it. I know, cheap and awesome. Micro sensors and lithium batteries. Yes. So originally, I tried to put this out as a Science and Technology Center proposal out of the University of Arizona, and my dean at the time said, no, I was too young, and it wouldn't go. And I cannot tell you how cranky I was. This is awesome. It will totally work. We should do this. And so I called my friend Jorge at Princeton and said, Jorge, have they got a spare spot? You know, you're allowed 3 of these. Have they got a spare slot at Princeton? He's like, I don't know. Let me call the dean. He called the dean. The dean said, yes. So yes, it's based at Princeton. I'm the lead for the modeling, and he's the director overall. And my friend Lynn Talley, who was actually a professor on my committee way back in the day, is in charge of the observational side, deploying all our floats. And what it did was it replaced, that's one of the robot floats. That's Becky Beedling, one of our students, who's now a professor at Temple University, putting our robot floats over the side. Let's see. Up she goes. That float will get 250 profiles, and it has pH, oxygen, and nitrate. It's got 6 sensors, chlorophyll backscatter for optical sensors. It's awesome. And this is the actual deployment. First time I gave a public lecture in Tucson was, I think, 2016. And so we had just barely started deploying these. And this only goes through 2020. This is Hannah Zanowski, who deployed our first set of floats. And this is her teaching her first big intro-oceanography lecture this year. She's a new professor at the University of Wisconsin-Madison. I know, it's so adorable. She said she's only got 65 students now, but she says next year will be bigger. I'm very proud because she started out in my intro oceanography class, and I had something like 600 students in it. And so having her send me her big class is like, yes, win. So we've been actually measuring the carbon dioxide. Now, the problem is we thought it was all supposed to go in, right? New human atmosphere full of carbon, we all burnt, should be driving it into the ocean. Where it's pink, it's coming out. The water is upwelling from so deep. This water is roughly 800 years old. It has never seen our human atmosphere, but it's been accumulating poop and dead bodies from all the phytoplankton and other fish and other rot raining down it very deep. And now the winds are blowing so hard, it's bringing it back up to the surface. Remember, I told you it's all that upwelling. I was like, yay, this is great. It'll help us with the air conditioning. Unfortunately, it's also carrying a boatload of carbon. Not good, not good. So we have this autonomous biogeochemical floats detect significant carbon dioxide outgassing. That was a shock. And that's one of our postdocs, Allison Gray. So what's happening is here is the Pacific, and you can see all this high carbon water from the rot of ages, making it all the way to the surface around Antarctica. Now, there's not as much coming in from the Atlantic because it's been recently ventilated, but it's also coming in from the Indian, where the water is old and has accumulated a lot of rot. And this is just the path spiraling upwards in a model. And this, all the red dots are measurements where the floats say it's burping out. And the blue dots around the edges of it are where it's still going in. That's a problem. So we actually, when we published these papers, we had a series of Nature climate change papers. The New York Times actually came to the University of Arizona's Cyverse, where we post everything. You want to see our data, you want to see our observations, you want to see our floats, you want to see the satellites we use, you want to see our data visualization, you want to see the climate model code, the climate model output, the climate model data vis. You don't want to see any of it, but we make it all public just in case. So they came and stole our, they actually stole our not stole, they borrowed, because we said they could. They took our model data and they used it to make this glorious digital interactive so you could actually see it upwelling. And then they laid all the floats on it so you could see it. It was brilliant. Journalism at its finest. Real science, really important. And by the way, we made it in the New York Times on the front page above the fold. Whoa. And then we got a really big monster global array funded. That looks like this. So we are no longer just the Southern Ocean. We are a global biogeochemical array of floats. And we are, that's me in the pink scarf in the middle, arguing with 9 of the 10 float deploying countries. We keep trying to get the rest of the world to do this with us, right? Because, you know, should the US really be all alone? And I'll just say our best allies, Australia and France, have come through. They've deployed over 100 of these themselves between the two of them. And, but we have over, let's see, 582, these are the American floats, in January 2024. So, and this is what it looks like. The brown is where the oxygen's super low, which is where the rotted water is, right? So this is just an estimate of where you would see. And seasonally, so in the summer it greens, and then in the winter it burps back out. That's what that is, and all of this incredible data. Once upon a time, the only data in the Southern Ocean for carbon, like pH, was the 3 cruises I did when I was in grad school. Yeah, it's bad. So it's complicated by the fact that climate is changing. We have really big growing winds. Now, we all know that we have westerlies in the northern hemisphere, which we get our winter rain from, and in the southern hemisphere. And then we have the easterlies, right? Our tropical rains in the summer from the monsoon come in with the easterlies. So you can see, here's our easterlies, and here's our westerlies. And of course, we sit under this dry zone, right? That's our, and notice that Australia also. So, you know, we trade off. First we burn, and then next season they burn. And then it's our turn again. Woohoo! But here, if you want to see it actually animated, this is the water in the atmosphere, all of it. This is real data. This is total water in the atmosphere. So you can see the easterlies poking along. Here they are, zoop, 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 zoop. And here are westerlies ripping along, you know, in both hemispheres. Now, the southern hemisphere is about 30% stronger than the northern hemisphere. Anybody want to guess why? Because there's a lot less land, which means fewer speed bumps, right? No speed bumps in the southern hemisphere. Northern hemisphere, we got the Himalaya, we got the, you know, the Rocky Mountains, we got the Alps, speed bumps. There are no, you know what, we got a little bit of Andes. That's it in the southern hemisphere. So they are really ripping, but this is what it looks like. So where we see the wave heights getting higher in the ocean from satellite, this is the altimeter data. Everywhere it's red, the waves are higher over the last 30 years, a lot higher. And there is no other way to make these waves, right? You could have a tsunami and they'll be 2 to 3 feet high. Wind waves are how you build big waves. That's the only way. You can't argue about temperature or salinity because the wind doesn't care and neither do the waves. This doesn't make any difference. This is just the evidence for it is a lot rougher out there. It is rougher because the winds are stronger, and they aren't just stronger in the westerlies, although that's primary. Here's, you know, our westerlies and our westerlies and our easterlies. I mean, we have a few little blue dots here, but not very many. It's rough out there. And it's making the mixed layer depths, like the really big exchange mixing by the wind. Where it's blue is where it's deeper. Yeah, everybody thought the oceans were going to stratify and get shoal and get warm and stagnant. Nope, we are headed for a warmer, windier, wilder world. Yep. There's the wave power increase, particularly in the Southern Ocean, but everywhere. We've seen a global acceleration of all those big currents, all of them, except the Labrador Sea Current, where we're dumping a lot of water off Greenland into it. Everywhere else, we've seen increased currents, everywhere. Everywhere. It's wild out there. And we know why. Originally, we thought that this increase in the westerlies would moderate eventually, and it was because we weren't going to have as big an ozone hole, which makes the atmosphere up high where the planes fly much colder and much warmer down below where, you know, we're warming, but the upper atmosphere, because we're warming, we're not letting as much radiation get out, so it's cooling up there. So we thought first there'd be this ozone hole recovery, and then there would be that greenhouse gas thing, but it would take a really long time. Nope. So the ozone, the stratosphere is still cooling, northern hemisphere, southern hemisphere tropics, and the ozone hole is as big as it's ever been. This actually is the record last year, 2023, the record largest ozone hole area ever happened last year. You all thought it was healing, right? Man, the news does not keep up with what's happening. And then here is so if it were healing, we would not be so much colder. Look at how much colder the last 3 years have been overall. It's just, this is -90 to -70. It's ridiculously cold. If you want to, but here, I won't make you watch little graphs. I'll show you what it looks like. Isn't this pretty? It's gorgeous. This is from the European Space Agency. Here it comes. And ozone hole. Yeah. Does that look like it's healing anybody? No, not even close, not even a little bit. And it's not because we're not cutting our emissions of ozone destroying chemicals, although there've been a lot of leaks and cheating, right? Turns out when we stopped emitting CFCs, we basically sold the apparatus for making them to people in China and India, who then started using them. I know. So, and just in case you thought it was only the Antarctic that makes ozone holes, I hope everybody's been stocking up on their sunscreen. So we've had some pretty big Arctic ozone holes. And we predict that this is going to continue and get worse. This is what has happened in the past in the gray and what will happen in the colors. And the reason we didn't know is because our satellites are only set up to help us with the weather. They aren't set up to do climate. So they haven't been looking very carefully at how big the storms are that aren't hurricanes. Yeah, I had to actually beg them for this satellite mission I wanted to run. I had to get a letter of commitment from NOAA to say I could take their P3 hurricane hunter to New Zealand and run it back and forth in the winter to Antarctica. And I thought that the teams would tell me to get stuffed because who wants to risk their lives in the Southern Ocean in the winter? And they all said, yeah, let's go. I mean, cowboy up. I'm like, woo! So they did say yes. We didn't win the satellite proposal, but the reason we wanted to go is here's all our estimates from the weather data of what the winds are doing. We basically are underestimating the storm winds. We're underestimating the max storm winds, and all the winds we're underestimating by about 30%, like almost a third. We're underestimating because we just don't measure it that often. And so a big storm goes by, we only got one little piece of it, and it wasn't even the biggest piece. It's terrible. So we proposed to put up another scatterometer and, bring the P3 hurricane hunters with us, satellite floats and the hurricane hunters. Come on, wouldn't that be badass? I would have loved that. We didn't get it. Some, they only give out one. There's a smaller mission being competed right now. And if they don't pick an ocean mission, we're going to go back and ask them for a global satellite next time. Which is in about 2 years. This is what it would have done from what the Europeans are doing right now, which is the red. We would have added our yellow stripes. So we would have doubled the number of measurements per day. So then we would be able to use the floats and the satellites to do global carbon prediction for the ocean. So I wanted to prove that it would work, this lovely global carbon prediction for the ocean. So, and the reason is I took a model, a data assimilation of the ocean, added in the floats, et cetera, and then added some wind. Assumed we were underestimating the wind by 20%, not 30. I thought I'd be reasonable and just give it a little goose of 20%. It flipped the sign. Instead of in, the Southern Ocean is now out. This worries me a lot. So we're going to test our Ocean Watch system against Carbon Watch New Zealand and then expand it to Oceania, i.e. all the ocean. And so Carbon Watch New Zealand, I spent last summer as a Fulbright scholar in New Zealand at the National Institute of Water and Atmosphere, because they have an actual monitoring system for their whole emissions, not just their emissions, but ag, the forests, wildfires, et cetera. And I said, maybe I could add the ocean side. I've had robot floats off New Zealand for 10 years. I got a lot of data. I have a great data assimilation. Maybe I could do something. And so they use atmospheric modeling plus the measurements to actually get a total impact. It's brilliant. But what they found out was about half was missing. They know how much they burnt, but what they're measuring was about half. Where'd it go? So they checked the cows and they checked the grass, and they checked the forests, and they tried to check the rivers, and they said, I don't see it. So I said, you're very watery. You're quite an island. How about I check your exclusive economic zone for you? And that's the exclusive economic zone around New Zealand. So this is the fraction of months with uptake of CO2, all the green. Yeah. And so we have this, right? This is data simulation. It's all done. Brilliant. So we did this for New Zealand's exclusive economic zone. We plotted it up. Turns out we nailed it. It's a 0.83 correlated with their output. So their missing sink is going in the ocean. We're examining this more. But so I would just want to, one tiny thing before we're done here. How are we spreading the word about this? Because I feel like most of you are pretty surprised that the ozone hole is not healing, that the ocean's taking up so much carbon, that it might be coming back out, that, this is what, methane is only not that big a problem. I mean, kind of like, and that we dropped so much off our carbon emissions. We made such a huge world impact, even new. So how do we spread the word? I have a little project called Science Moms with Catherine Hayhoe, she's from Texas, and her husband's an evangelical pastor. And we thought we would just talk to moms because we're both moms and we're both climate scientists. And we thought they could use a kind of a trusted ambassador to tell them simple stuff that everybody should know that maybe they didn't get in school because it's been so long and they didn't have climate science back then. So these are all the science moms. It's lots of fun. We have over a century of experience together. We all have a bunch of kids, and we just wanted to make sure that everybody had the best information, reframe the problem, explain what's at stake, build your confidence to talk about it, and make solutions achievable, and then tools. And
what's the plan to solve climate change?
Sorry,
Science Moms present What to Do You. Hi, I'm Dr. Joellen Russell, but you can just call me Joellen. I'm an oceanographer and a mom. Here's the deal. Moms are worried about climate change, but a lot of us don't know what to do and don't feel like we can make a difference. You might find yourself thinking, how can me, one mom, possibly make an impact on one of the biggest issues facing humanity? But the answer's simple. You aren't alone. There are more than 85 million moms in America. That's over 175 times larger than the U.S. Army. And a lot of mom power means a lot of impact. Moms help women secure the right to vote and help stop child labor. They even turned Mother's Day into a national holiday, giving all moms the one thing they really want, a freaking day off. There's nothing more powerful than moms on a mission. So the Science Moms created the one thing all moms need to take action, a to-do list. First, swap. We're swapping carbon-polluting stuff for clean stuff. Next time you're in the market, swap out things like gas cars and stoves for electric ones. You can also get your actual electricity from cleaner sources. Most places have at least one clean energy provider. Second, we're sharing our concerns about climate change and what we're doing to help. Spam your feed, blow up your group chat, or even use your phone, as a phone. Because the more we talk about making changes, the more important making changes becomes. Last, but definitely not least, speak up. We're speaking up and asking our leaders how they plan to stop big polluters. Because it's time for our representatives to, represent our interests, like, our kids having a future. So yeah, that's it. That's the list. We can swap, share, speak up, or do them all. We can count on you because moms get stuff done. And even when we don't want to, we just end up doing it anyways. Check off your to-do list at sciencemoms.com.
I know it's a little silly, but at the same time, it's nonpartisan, nonprofit, and Mackenzie Scott Bezos has basically funded the whole shtick, everything. Soup to nuts. It costs none. We don't take donations. There's none of that. All we're trying to do is get the word out. And basically it should be short enough so that you can watch it on YouTube while in the carpool lane. Simple, straightforward. And I want to tell one last story. He's the world's most famous oceanographer. In the running with Stan, of course. And Walter Monk, I'm using the equations he pioneered when he was a young man. And the reason he was looking at those wind wave equations was he was trying to do the forecast for the wave heights on D-Day. And the reason is that they had low gunnels. At 6 feet, the boats would swamp. At 5 feet, they'd be safe and make it in. So you want bad weather, as bad as you can get to keep the Luftwaffe off their backs. At the same time, they can't get too bad or the boats will swamp and they'll die. So Walter was, as a young man, he did this service. He was the last call Eisenhower made before he called D-Day. He is our most famous, right? And I still use his work. But he gave the plenary at the Ocean Sciences meeting a few years ago before he died. And he said, Hitler was my generation's greatest challenge and climate change will be yours. You could have heard a pin drop. And we had half of all the oceanographers in the world in that one room. Really, it's a big deal and there aren't enough of us and we're going to need a lot of help. It is that bad. So we're going to keep building out the carbon observing prediction system, implementation of our near real-time carbon accounting. We'll publish the top 10 economies carbon bill and hopefully save the planet or at least the humans. Thank you. I'd love questions.
Yeah, I wonder if you could go over again why the winds, the westerlies are increasing, why we've got an ozone hole again.
Okay, ozone
That
hole
wasn't clear.
was primarily caused by chlorofluorocarbons.
Yeah, and they're gone.
No, they're not.
Oh,
In fact, the reason they're not, they've
Oh, go on.
decreased, but not fast. And the reason is that there are a lot of leaks and cheating. Second, the stratosphere continues to cool because the first problem was how much of these ozone destroying chemicals there were. The second problem is it's gotten a lot colder and we're basically creating ice particles that are little Death Stars for ozone destruction. They make the chemicals that destroy ozone much more efficient because you stick one to an ice particle, which is huge compared to a molecule. And just mow down a whole bunch of ozone all at once. And that's been happening more and more and more. So it is getting colder in the stratosphere while the troposphere, our lower atmosphere, is warming. And the thermal wind equation says the bigger the difference, the bigger the gradient, the stronger the flow. So the more it cools in the stratosphere, the more it warms in the troposphere, the bigger the ripper. And that's why windier, wilder, warmer world.
Question over here.
Joellen, one of the tipping points that I've always been kind of concerned about has to do with the frozen methane, both in the tundra, which is beginning to thaw, but also in the methane clathrates in the deep ocean. What are you seeing in terms of temperature changes that could jeopardize those things beginning to sublimate?
So you could see it in the tundra, but if it's happening, it's not that, as I showed in the radiative forcing, it's just not that significant yet. It's possible. In the water, of course, I'm not worried at all. And the reason is that the reason that they're frozen is not the temperature, it's the pressure. And the pressure is only going to get more, not less, because of sea level rise. We are melting our Greenland and our Antarctica and all of our glaciers in between. Glacier National Park will shortly be national park. And all that water is ending up in the ocean. We've seen significant sea level rise, which is only contributing to the pressure on the clathrates. So I don't worry at all about clathrates mobilizing at all. But it's possible there could be some permafrost move, but we've seen a lot of warming and a lot of permafrost thaw, and we have not. And I'll just say one of the things is when it's on land, we have methanogens, actual both bacteria and plants. Methanogens eat it. So we are not seeing as big an impact from permafrost thaw as we might have. Now, I'm not an expert. That's terrestrial and it's plant veggie things. But I am told by my veggie colleagues that I know, I'm terrible. I'm so sorry. But I teach this wonderful global change class in the fall with Professor Scott Zaleska, who does, he is a terrestrial ecologist. He's brilliant. And so we have this ongoing argument about ocean versus land, and he thinks he's winning. I am not super worried about methane, and that's why I put that in. It's not that it's not important. It's just not that big compared to tanker loads of fuel.
We've got a question online. Michael Rees, I've just unmuted you. You can ask or you need to unmute yourself, I guess, and ask your question.
Oh, thanks. Just a question about solubility of CO2 in water. Does it increase with temperature? I assume that it does. And if so, does that mean that the water, the oceans will hold more CO2 as they get warmer and help slow down the release of CO2 into the air? Or is the concentration so low compared to the total solubility that it doesn't matter?
Actually, the colder the water, the more soluble it is.
Oh,
So colder ocean can hold more. And so global warming and warming of the ocean means it can hold less. So when the water upwells and is warmed, it actually not only degasses that ancient carbon, it also degasses a little bit extra because it's warming.
thank you. Yikes.
Yeah, yikes is right. Thank you. Good question, though.
So microphone here.
That was fabulous. I just have to say, what you've really proven is that everything is connected. Everything.
Mhm.
And we've been studying it bit by
Bit by bit.
and now you're connecting it. So the only way I can understand the future in this hugely connected system is to ask a stupid question.
My
Which
favorite.
is, let's stop magically all the emissions of CO2 right now, this week. Tell me what the trajectory of the world looks like over time.
That is a wonderful question and one we haven't addressed nearly enough. What happens if we decrease our emissions? If we actually bend the curve, start on our way back down, or just zero it out? So at first, we would see like lockdown. Everybody was like, great, lockdown, right? We really abruptly stopped our emissions, not all of them, but a big chunk. Because that meant we also reduced the aerosols from burning, the little particulates from burning. We had all this road dirt and road emissions. So the CO2, we didn't emit as much, but what we were normally putting out over the globe was is slightly cooling. It reflects CO2. Reflects the sunlight's back out. So in fact, when we locked down, we had zero slowdown in the growth in the atmosphere that first year. No slowdown at all, even though we cut our emissions by 8% globally. And it's because the aerosols are slightly cooling for us. So if I do this experiment, I have done this experiment where I shut it off, we actually have some wobbles to begin with, where we'll keep emitting from the ocean. The ocean will give some up because the warming will continue and will still melt. Now, eventually, within 30 years, you'll start to see a moderating in that extreme heat in the summer. But for the first 30, it's going to be very hot because we will have fewer people will die due to bad air quality. And that's actually a lot of people. But we will also see it continue warming for quite a while. And after about 30 years, we might see it start to moderate. It will take some time, but it's a glorious problem and one that I would love to be dealing with. Part of it would be too that the length of time in the atmosphere would start changing. Personally, I think I do want to see carbon dioxide removal, but only for the 4 to 6% of emissions that we can't quit. Things that have to be high temperature, like smelting. Like if you need to turn new metal or recycle metal, you have to heat it. Heating is just easier to burn something rather than do it almost any other way. That doesn't mean it's impossible, just that that's going to be a toughie to get rid of compared to almost anything else. Flight, too. We're having a hard time changing jet fuel for something else. Of course, our nuclear subs have zero emissions, but just saying. So there are many good options, but we would see some bumps, but 30 years, it should start to moderate.
When the question of climate denial came up, let's just say in general, I sent an email to Joellen and she shot back immediately saying, ouch, how can I help? And this is how she can help. Thank you, Joellen.
It's not about, it's the way I think about it. I don't actually feel, I'm not upset by climate folks who have trouble with climate science. One, if you're over the age of 50, you did not get this in school. Ever. We didn't know this science yet. We hadn't built it. Now there were the underpinnings, the thing, Dave Keeling had started his series in 1958. So we have known a very long time. Jim Hanson's testimony to Congress is in 1983 saying global warming is here. These are, there is a fine tradition, but my friend Ron Stauffer, who now works with me here, who used to run the climate models at GFDL, he had death threats in his mailbox where his children sleep. It has been an ugly, ugly thing, but I stand by and will show you the calibration for my sensors. We'll show you the vast quantity, thousands, tens of thousands of measurements. That's why we are 100% transparent, why we share every line of code. We show all of our data. We show all of our work. I can recreate it. My students can recreate it. And there is absolutely no evidence that we've gotten it wrong. There isn't any. It's okay that we didn't know this, and if you had made up your mind in the 90s when, it wasn't quite so obvious, you're forgiven. Come on in, the water's fine. No, really, seriously, I have no worries with folks but these days, I'll just put it, I don't worry so much about climate skeptics anymore because I get invitations to talk out in the hinterlands here, out in the farm country at the community center, with people kicking the mud off their boots and asking if they can leave their hats on. And these are farmers and folk who are worried about our mega drought, worried about how hot it's gotten, worried about making plans for their families and their wells. And why would you call an oceanographer? This seems just silly, except it's why this is how we know. This is how we predict. If you like your weather forecast, thank an oceanographer. And the fact that Arizona farmers, and Montana farmers, and maybe some in Utah have figured out that an oceanographer can help, that we are in fact integrated, and it is one problem, is just it. I am not worried about climate skeptics. If I can help with farm folk, we're okay. We're going to be all right. We're one. We are we. There's not an us and a them. We all live on this tiny spaceship Earth, and we're all doing this together, urban and rural, right and left. This is all about making the world a better, safer place for our great grandchildren. And I don't worry for a second that there's anybody in this room or any other who isn't interested in that.
We had one other question online. The person left, but they were kind of curious about the floats and do they affect shipping lanes or what?
I didn't put in the little video, but we have, if they sit at 1,000 meters down, they have never bumped into any boat. They sit at 1,000 meters down and for 7 days, and then they drop down to 2,000 meters, 20 football fields down. Then they do a profile of measurements, with the microsensors on all the way to the surface, and immediately within 5 minutes of beam back a burst of data by Iridium satellite to, you can see them that minute. We post it online on the global telecommunication service for all the weather forecasters so they can use it, and we can data assimilate it into our models. So the floats are back down within 5 minutes. They have never hit anything. We've never lost one due to a ship strike. It doesn't happen. They have no EM signature, and we even made the housings edible. Eventually the bacteria will eat them.
Hi, I have a daughter who is along your lines. She teaches environmental biology and oceanography at Orange Grove College.
Nice.
I'm sure she would love to have information that you could give her, because here she is teaching the young people about the environment, and she is so into that, recycling, environment, global warming. I go to her classes and it's like, I'm in awe that this is my child who knows all this. But is there some way she could get information from you to get her classes?
Well, absolutely. Plus, all the slides are documented, have links to everything I'm citing, and I make them freely available. I think Ollie said they'd post them, or I'll put them in a Dropbox where anybody can have them.
Okay,
But
I would
he's
like,
more than welcome to contact me too. I am a public servant of the
Okay.
great state of Arizona and the nation,
If
and I
she's
am
in California.
delighted. Doesn't matter. I am happy to help in any way I can. And yes, absolutely, everything is public.
yeah, we need more young people teaching young people, about the climate. 'cause They
Absolutely.
just don't realize how bad it's going to, if they don't get going.
Well, in fact, we are getting going. That's the best news ever. Every time my kids are like, Mom, you can't buy that new. I see there's an Amazon box there. Mom, just wait till Saturday. I'll take you thrifting. Fine. Gosh, they're on it though. Boy, are they.
Those floats are pretty impressive. How long do they last before the battery dies and
So the temperature and salinity only ones last 7 years to 10. Okay. Everybody's heard about that vaunted German engineering. Want to know whose floats don't last that long? Yeah, no kidding. I cannot tell you how much I enjoy giving my German colleagues grief about the fact that their floats can't beat ours. The BGC floats don't last as long. We have 8 sensors, and even though we pack it with lithium batteries, et cetera, they only last about 4.5 years now. The newer ones are lasting over 5 now, but the older, and that's the longer they last, the more profiles they do. When their batteries finally die, the reason we try to make them mostly edible is because they can't make it back up to the surface. They just don't have enough energy to bring themselves back up. It's a bladder that fills and empties in order to help hoik themselves up through the water. And it's eventually they die. That's why there's one rotting in a tank at the University of Washington. If you'd like to see it, it's on its way to being eaten by the bacteria in the tank. So we just wanted to make sure everybody understood we're being green and sustainable, Believe me, those kids, they keep you honest.
We can leave this room and do as individuals.
Well, for carbon, swap, share, speak up. Swap whenever you can from carbon emissions to non-carbon emitting, burning to non-burning. Whenever you can, electrify everything as much as you can, thrifting is also great. Anything you can keep from ending up in the landfill is better. Trade with your neighbors. New to you is great. Everybody should be thrifting as much as they can. Reduce, reuse, recycle, because then we're not using as much energy to create new things. We're just reusing the stuff we have, making it get to the right home. That is great. Share whenever you have a triumph or it works, or you're just having a good time and you found something great at the thrift store. Put it on your Facebook, share, so that that's how we make a movement, is we basically get everybody understanding this is fun. We're good at this. We know how to do it. Let's do it together. And then there's speak up. I have, and a bunch of my mom friends, we have a routine on Saturday mornings with our walk. We all exercise Saturday mornings because we're, and so I put my headphones in and I have a speed dial list of 10 of our representatives that I just call their hotline. They're never in, it's early in the morning, right? So I just get the voicemail, but I say, hi, my name's Joellen. I'm one of your constituents. And I just want to ask you what you're doing to help stop big polluters and carbon dioxide in the atmosphere, because I'm really worried about global warming. And if enough of us do it, eventually it moves up their list of priorities, et cetera, because they actually have to write you a letter or respond. It's, their constituent work, to you, especially if you directly contact them and give you more information. So I have 10 of these that I do on a Saturday morning every week. They'll be hearing from me. And it's just, it's not a big deal, but I feel like it's part of my job to, I'm going to bird dog these guys so they do something. And by the way, Arizona Corporation Commission, everybody needs to vote.
Back here.
I'm just curious how you see the future, given the trajectory in China and India. Can we get the mothers in China and India involved here
I
too?
think so, but better yet, I think that two things. One, monkey see, monkey do. And two, nobody likes it when business rivals get a leg over. We are reducing friction in our economy. We are making ourselves more self-sufficient. We are reducing the amount of effort and lung cancer and deaths from air pollution all the time. All the time. This is better, healthier living for all of us and cheaper potentially. So I feel like this is something where if we get it right, who's going to be selling electric cars? Is it going to be us or them, right? We just had 2 massive lithium strikes in the US, unidentified previously, and I'm thrilled. We're going to be building our own batteries. We don't need their lithium, right? And if we do it right, robot factories, et cetera. I mean, look, I feel like there's an opportunity for, I don't think that India and China want to be under coal. I think they'd rather jump that hole into distributed, right? Where solar panels on every roof, solar farms, wind farms, wave energy, geothermal, nuclear. There are all these different ways that we could just skip the fossil fuel revolution in lots of the world. They don't need to spend time on that pathway when it's dirty and bad for them, right? If we could make the technology better, cheaper, easier to deploy, you know, and oh, by the way, it might have to be our engineers who either sell it to them or come consult, you know, wouldn't be bad for us either. And great for the planet. So the sooner we get it done, you know, nobody thought solar panels were going to work, right? They all said, oh, you know, those aren't going to get cheaper. They're going to be expensive forever. BS, they're cheap as heck. No, seriously. There are many good things. I have to say, I'm also biased towards nuclear because my brother is the associate director at Idaho Falls National Lab, and they're all about little miniature nuclear, you know, power, et cetera. And I keep thinking, geez, you know, if we basically had our water system with a nuclear power plant cooled by gray water, essentially, so we could distill the water, turn it back into tap water, pure, perfect distilled water, and at the same time have our lovely little nuclear plant providing all our power. I'm like, dude, we're done. You know, Tucson's got everything they need, just a little trickle of extra water, we'd be good to go, you know, for our vegetation and all the rest of it. I mean, just keep imagining these better futures. And there's no place like Arizona who already knows we have to engineer our environment to keep ourselves safe. And the innovation that, you know, in solar and in everything else around here, I feel like we're the right spot. We're the right spot to try this out. Plus, you know, Tucson's full of engineers and scientists, and you know, this is I love living here. It's my favorite.
Well, I want to thank you, Joellen, for this wonderful presentation, and thank everybody for coming out, and those of you online as well for joining us today. And Brian for helping put these together. And we're looking to continue the conversation this fall. I think.
Team effort. Thank you very much.